Hello, welcome to the class. Today we are going to solve the problem which is given in JEE 2026 Advanced. Let's dive into the problem. A quasi-static cycle of monoatomic gas contains an isothermal process AB followed by an isochoric process BC and an adiabatic process CA as shown in the figure. The volumes of the gas are V1 and V2 at A and B respectively. If the cycle has heat input Q in and output Q out, then the efficiency of the cycle is defined as eta is equals to Q in minus Q out over Q in. The logarithm value log 2 is equals to 0.7 they have given, and here is the graph and options. What are the options? Let's see. A. If V2 over V1 is equals to 8, the heat released in the process BC is smaller than the heat absorbed in the process AB. For a given value, V2 over V1, eta does not depend on the temperature of the isothermal process. Option C is if V2 over V1 is equals to 8, then the temperature of the gas at A is 4 times the temperature of the gas at C. If V2 over V1 is equals to 8, then the pressure of the gas is at A is 4 times the pressure of the gas at B. These are the options. Let's solve the problem now. Yeah. Okay. It's done. Okay, this is the diagram with P versus volume, pressure versus volume. Here is the V1 and here is the V2 value, and they stated that from A to B it is an isothermal process. From B to C they stated that that is isochoric process. From C to A they stated that that is an adiabatic process. As we know that in isothermal process the internal heat exchange is equals to the work that is done outside in externally on that process, so that Q is equals to W. Delta U is equals to 0. This means what? The internal change that taken place in that process, isothermal process, that equals to the 0. That means there is no internal change, internal energy change taken place in this isothermal process. In the again here is the temperature is the constant. T is the constant. W is equals to nRT L logarithm V2 over V1. Okay, next in isochoric process. Isochoric process, the heat exchange that equals to the internal change that taken place in the process. And as we know that there was no externally work has taken place in this isochoric process, so W is equals to 0. Next, here V is the constant, volume is the constant. See, volume is the constant. In adiabatic process, as we know that there was no heat exchange taken place, so that Q is equals to 0. From this, we have to find from adiabatic process, as we know that T1 over T2 is equals to V1 over V2 to the power of gamma minus 1. From this, in options, they have given stated that V2 by V1 is equals to 8. So that I am writing here it is in reciprocal process. Okay, T2 over T1 is equals to V2 over V1 to the power of gamma minus 1. Okay, from this, I'm writing as a T2 as T2 mention T2 as a temperature at B. I'm sorry, it is adiabatic condition. No? The temperature starts, the adiabatic process starts from C to A. So that T2 is here TA and T1 is here Tc. That is equals to V2 over V1 to the power of gamma minus 1. From this, as we know that TA over Tc is equals to V2 by V1, they have given 8. Gamma value we know that 5 by 3 minus 1. From this you get TA is equals to 2 to the power of 3. I am writing 8 as a 2 to the power of 3 and here you get 2 by 3. 3 cancel here. You get TA is equals to TA is equals to 4 times Tc. Okay, 4 TA is equals to 4 times Tc. What is the option given? Okay, see, V1 at V1, V2 over V1 is equals to 8. Then the temperature of the gas at A, temperature at the gas at A is 4 times the temperature at the gas at C. It is satisfying, no? Yes. The temperature at the A is equals to 4 times the temperature at the C. So that option A, options, which option it was C. Option C is right answer. C correct. C is the correct option. Okay, then go for the pressure. We know that at ideal gas stage, P1 is equals to P2 V2. From this you get P1 over P2 is equals to V2 by V1. At which stage they are asking pressure? Pressure they are asking at A and B. Okay, pressure they are asking at A and B. P A P B is equals to V2 over V1. This implies PA is equals to V2 by V1. We know that 8 into PB. Okay, how much it is? The pressure at the A is 8 times the pressure at the B. So that the option D is wrong. Option wrong answer. Okay, they have stated that it is 4 times, but we have erased it's 8 times. So that option D is incorrect. Incorrect. Okay. Next. Let's go for the comparison between the heat transmission in between adiabatic process and isochoric process. Okay, let us go for it. W is equals to nRT logarithm of V2 over V1. Okay, here nRT logarithm V2 over V1, that is logarithm 8. nRT mean logarithm 2 power cube. I am writing it as a 2 cube. Okay, from this you get n3 nRT logarithm 2. Logarithm 2 value they have given 0.7. 3 into 0.7 nRT. From this you get 2.1 nRT W. W is nothing but we have seen it is a Q. Q at isothermal process. Okay, next. In isochoric process, what is the heat transmitting? Q is equals to delta U. Delta U, as we know that delta U is equal to NCV delta T. And CB value we have know that 3 by 2 R. Delta T. What is the delta T? It is isochoric process from B to C. Okay. TC minus TB, the difference between the temperatures from C to B. C and B. And 3 by 2 R is equal to TC. From this equation you get the TC value. TC is equals to TA by 4. Okay, TA by 4 minus TB. What is the TB value? The temperature at the B is equals to the temperature at the A, because it's a isothermal. Temperature is the constant. So that in the place of TB I am writing TA. From this you get N3 by 2R minus 3TA by 4. Okay, from this you get minus n by 9 by 8 nRTA. Here minus denoting that, minus symbol denoting that the heat is releasing here. The heat is releasing. Okay. Delta U. Delta U is nothing but here Q. Okay. Now let us compare at isothermal process and at isochoric process, the heat, how much heat difference is there. Okay, they ask that which one is smaller. Okay, for that at isothermal process W is equal, Q is equal to 2.1 nRT A. At isochoric process it is minus 9 by 8 nRTA. Minus 9 by 8, that means 1.25 nRTA. Q is equals. So that which they stated that in options. In options they stated that if V2 over V1 is equals to 8, the heat released in the process BC is smaller. BC is smaller than the heat absorbed in the process AB. Okay, is it satisfying now? Yes. This absorbed heat in the isothermal process is greater than the heat released in the isochoric process. So it is also, the A option is also satisfying. So option A is option option A is correct. Okay. Last we have one another option, that is B. So for that I'm getting some problem issue. Let us resolve. Okay. Now, the efficiency of the cycle, eta is equals to Q in minus Q out over Q in. Okay, from this you get Q in over Q in minus Q out over Q in. Okay, from this you get eta is equals to 1 minus Q out over Q in. Okay, from this, what is the Q out? Q out is the heat is releasing from the isoporic process. Okay, so that you can write this one isoporic. In isoporic process, what is the formula? NCV delta T. Delta T, what is the formula for it? Delta T is T B minus T C by Q in. What is the Q in? Isothermal. From isothermal state, from A, the process is starting, so that it is a Q in. It is transforming, releasing. Sorry, heat is transforming from A, so that what is the formula for it? W nRT logarithm V2 over V1, that is equal to 1 minus n. CV value we know that 3 by 2 R, and here I am writing TB. What is TB? TB is equals to nothing but TA. So I am writing TA minus TC. From this you get TC. TC is equal to T by 4. Either TC is equals to TA into V1 by V2 to the power of gamma minus 1. TA V1 by V2 to the power of gamma minus 1 over nRT logarithm V2 by V1. This is equals to 1 minus nRT and okay, n 3 by 2 R T. Let's take out the T, temperature at the T. A, take out 1 minus, you get V1 by V2 to the power of gamma minus 1 over nRTA logarithm V2 by V1. From this you can cancel it, nRTA. You will get 1 minus 3 by 2 into 1 minus V1 by V2 to the power of gamma minus 1 over log V2 by V1. Okay, this is the efficiency. In this formula, there is no T. This means what? The efficiency in this process from A to B, B to C, C to A, the efficiency does not depend on the temperature. Okay. So, what you get? The option B does not depend on the temperature. The eta does not depend on the temperature V2 over V1. Okay, it is satisfying. So, option B is correct. This is all about the class. Thank you. Thank you very much.